Hello, this is Timberlake Basic Chemistry, and we are in Chapter 8. This is the second section of balancing equations. So today we're balancing equations with polyatomic ions. And I'm not sure that you're good enough at polyatomic ions. You have to have some of this in your memory to know, first of all, what it's called. Secondly, what its charge is. If you knew something was -2, then you could combine it with 2 positive 1s or 1 positive 2, or you could configure it as long as you know what the charge is. It's hard to do that. You almost need a little bit of memory work. You could figure it out, but who would? Nobody would. You simply learn 20 different polyatomic ions, and then as you put things together, think of a polyatomic ion as one Lego that's bigger than all the others. It's made up of different atoms, but think of it as one Lego. It combines just like an element does, even though it's made up of more than one element. It would have a -2 or a -1 or a -3. There are polyatomic ions like ammonium, which is NH4, which is +1, but almost all are negative. Okay, so if you are going, there's an example here. Write an equation using the correct formulas in the reactants and the products. Okay, so magnesium is originally combined with chlorine, so it's magnesium chloride. Sodium is combined with a polyatomic ion, which is called phosphate. Normally anything with oxygen in it, the P, in this case phosphorus, plus oxygen is phosphate, and it happens to be -3. All right, so you can see here that if sodium is +1, since it's in group 1, it takes 3 +1s to balance. So you could figure out that that's a -3. Okay, so you could do that. Chlorine, the magnesium is in group 2, so it's +2, and chlorine's in group 7. That means that it's -1, so it takes 2 -1s to balance with a +2. It takes 3 +1s, sodium, to balance with 1 phosphate, so therefore phosphate must be -3. Well, if this is +1 and this is -1, it balances nice. And magnesium is in group 2, remember it's a 2, and phosphate is a 3, so when you cross them, the charge becomes the subscript on the other side. So when you're balancing, you simply have to make sure all of the charges are balanced. So I never break up phosphate into phosphoruses and oxygens. I figure phosphate almost all the time is going to stay phosphate. It'll simply have a different cation, and then at the end it'll have a different cation. Now I'm not saying that's 100%. Sometimes they do break up, but many times they don't. So unless I absolutely need to break up a polyatomic ion, I'll leave it alone and just think of it as an element. Right? So when you make sure that you have all the charges, right? So you have 1 phosphate, say, on the front, and you have 1 on the back, or you have 2 magnesiums on the front and 2 on the back, then you've balanced it. So let's try some examples. Balance and list the coefficients of the reactants and products. All right, so we've got iron, and I don't remember iron is in the transition metal, so it can be iron 1, it can be iron 2, there's all numbers of them. I think this is iron 3. The reason why is because oxygen is -2, so if I were to have a charge there, it's never written, but if I had a charge there too, it becomes the subscript. And then this is the 3, so that's iron 3 oxide, okay? Plus carbon yields iron metal plus carbon dioxide gas. All right, so let's do oxygens and hydrogens last. So in this case, we'll do the oxygens last. So I'm going to start here. Let me erase this to make it easy. Okay, I'm going to start on this side. I've got 2 irons, so I'm going to put 2 irons on the other side. I've got 1 carbon and 1 carbon, so far so good. Okay. Now let's do oxygens. I have 3 on the left, 2 on the right. I need a multiple. So multiple between 2 and 3 is 6. So I have 2 times 3 is 6, and 3 times 2 is 6. All right, well that messes everything up. So let's first of all do iron. Iron is now 2 times 2, so there's 4. So I'm going to erase this one and make this as 4. Okay. It also messes, I've messed up the carbon. So on the right, I've got 3 CO2s. That means I have 3 carbons. So there'll be 3 on the left. Now let's see if my oxygen's still okay. On the right, I've got 3 times 2 is 6. On the left, I have 2 times 3 is 6. I think that's good. All right, so I see 2, 3, 4, 3, and that is one of the choices. Okay, let's do another one. Do oxygen last. There's no hydrogens. So we have Al on the left, 1. On the right, we have 2. So I'm going to come back on aluminum and double it. And remember, you can't add subscripts, you can only add coefficients. You can only double or triple the molecule. You cannot change the molecule because nature knows how many Legos it needs, and you can't change them just because you want an extra aluminum in there. All right, so iron, I've got 1 on the left and 1 on the right. So far, good. Oxygen, I've got 1 on the left, 3 on the right. So I'm going to come back over here and make 3, but that messes up my iron. So I have 3 irons on the left, 3 irons on the right. And so now I have 2, 3, 3, 1, and that is your first choice. Last one, aluminum, 1 on the left, 2 on the right. So I'm going to come back over here and double that. All right. Now I do have hydrogen. I do have oxygen in the sulfate, but I'm going to leave that alone. I'm going to keep sulfate as sulfate and do hydrogens last. So that means I've got 1 sulfate, SO4. Over here, I've got 3 sulfates. Do you see that? The subscript tells me the entire sulfate's tripled. So I'm going to come back over here and triple the sulfuric acid. Right? Now, what else do I need? I need hydrogens. Okay. So on the left, I've got 3 times 2, I've got 6. And on the right, I've got 3 times 2 is 6. I think that's it. So it's 2, 3, 1, 3. 2, 3, 1, 3. All right. Hope you're learning.